antenna technologies. So this is the objective. Describe the definition and function of antenna. Describe the antenna performance and the specification and also the common passive components. Okay, the content number 1, antenna concept. So this is the definition. The radio wave is a type of an energy emission form. So during emission, electric field and the magnetic field are mutually vertical. In addition, the two fields are vertical to the transmission directions. Because we know the electric is always up and down, so they can't able to move by itself. So unless we're using some other energy to push it. So this is the reason why they're going to combine the magnetic field and the electric together to become the electromagnetic field. So as you can see on the figure here, the pictures, they're showing the energy. Okay, this is the blue color is belong to the magnetic field. They push the electric to forward, and so this is the reason why that you can able to see the radio wave is actually derived by this way. Okay, the radio wave. So that got the reason behind. So frequency and the wavelength. Frequency is a frequency of the vibration of or the number of passing wave in 1 second. So when the frequency passing in 1 second, like this one, we will call as a low frequency. If they can able to do the many vibration within the seconds, or they finish one vibration, not even reach the 1 second, so they can perform the high frequency. So this is what we call it. Wavelength refer to the distance between the same point in two adjacent periods. That is the transmission distance in one vibration interval. It can be also represented by the distance between two wave trace or truth. Okay, this is the wavelength. So polarization. An antenna, the antenna emit the electromagnetic wave to around space. The electric field vector always changes in certain regular. Okay, this is for the electric. Antenna polarization refers to the electric field vector generated when antenna emit energy. So if the electric field vector is perpendicular to the group, the wave is vertical polarized wave. If the electric field vector is in the parallel with the group, the wave is parallel polarized wave. And this is the electromagnetic wave emission. So this one will be based on the conductor. Okay, when the conductor is transmitting alternating current, electromagnetic wave emission is generated. The emission capability is decided by the conductor length and the shape. So like here giving the 3 different figure. As you can see, the figure number 1. So the conductor is very close to each other, is very close. So those kind of the electromagnetic wave is only can focus on this area. So when they're trying to come out from this conductor, so this is a reason why the energy will be transmitted by this way. So for this kind of the figure number 1, we will call this is the directional antenna. Okay, they only can shoot to one directions. The figure number 2. So the conductor is slightly open, so you can see this far away from each other. So when the energy is released out from their antenna, okay, they will keep refract. So by this way, so they can cover even wider distance. Okay, and the last one, the figure, when the two conductor is very far away, and this is 180 degree, so they can become the this is the omnidirection antenna. Okay, they can cover the surrounding. Antenna definition and the function. So the device that can be effectively emit the electromagnetic wave to certain orientation, or can be effective receive the electromagnetic wave from certain orientation. The function. The antenna on wireless device transmit and receive the electromagnetic wave. So the energy conversion between the wave and the free space wave, conversion between the high frequency current and the electromagnetic wave. So either emission and receive in a certain direction. So this is the antenna type. So there are many types of the antenna. For based on the function, communication antenna, and also the TV antenna or radar antenna, all is based on the function. Those antenna is based on the frequency band. Is those the shortwave antenna, the ultra shortwave antenna, and microwave antenna. Based on the direction, so they only have two types: omnidirectional or the directional antenna. For the shape, linear antenna and the plane antenna. Okay, below here is some of the example antenna. The working mechanism: half wavelength symmetrical dipole. So the basic emission unit of antenna. So the longer or the wavelength is, the larger the half wavelength dipole is. So the single half wavelength dipole can be used as the feed of the parabolic antenna, and the multiple dipole can be used together as antenna array. Okay, this is the example picture. Okay, the antenna pattern for the direction. Transmit energy from the feather to the air. The most energy to the required direction. So in another word, this is the directional antenna. So you only focus on a certain direction. Okay, it's not the surrounding. So they only focus on one zone. The antenna pattern shows the antenna direction feature. So the ability of emitting and receiving the electromagnetic wave in each direction. So when you look at the top, okay, from a top view, the horizontal plane, so you notice there actually is one big circle. It's 360 degrees. On the side view, the vertical, so you notice this is the antenna. So they have a two circle around the antenna. Of course, in the 3D view, okay, the 3-dimension view, so it will be look like the donut. Okay, this is the coverage. For the energy focus, when the pattern becomes flat, the signals are focused. Okay, so this is how they actually focus the signal. To the directional antenna, the refractor reflects the electromagnetic wave to one side to enhance the gain. So we know the omnidirection without the refractor, it can be able to cover the surrounding in 360 degrees. And once we put the refractor on one side, so it will go to refract all the signal on the left, all focus on one side. When all the signal step together, okay, when they have the same phase, have the same amplitude, at this level, all the energy will be focused. And back again to the polarization. The orientation of antenna in the plane perpendicular to the transverse wave direction of travel. So they have a different type of the polarization. Okay, vertical, horizontal, okay, 45 degrees, okay, with a different angle. And also, they're going to mix both together, make them can have a better receiver and transmission speed. Okay, using this. Okay, vertical plus the horizontal. or the plus minus 45 degree. Here is some of the list of the common WLAN antenna for indoor use. The first picture showing the indoor omnidirectional ceiling mount antenna. Okay, they have two different types. For the indoor directional antenna, okay, it's only cover for one direction. So normally this one will be put at the walkway, okay, the corridor, okay, this kind of area. They cover for the entire place, okay, but in one direction. And the last one is very common, see? So it's the indoor omnidirection whip antenna. So most of the AP also using this type of the antenna. Then the next one, the outdoor antenna. So this one can support 2.4 and 5 GHz. And the coverage is the omnidirectional. Then the second one will be the directional. Okay, so this one is basically deployed at the outdoor and cover for far distance. And the last one, outdoor backhaul antenna. They cover even further distance. So this is mainly using for those of the bridging mode, okay, WDS or maybe the full mass connection. Number 3, specification. Okay, the gain, coverage area. When input power is fixed, gain is the ratio of radiation power in certain direction to the radiation power of the reference antenna, usually an ideal radiation source. So right here you can see on the picture here showing the low gain and also the high gain. So when you're purchasing those of the antenna, showing the gain is just around like below 10 or maybe it's 3 dBi or maybe 5 dBi. So don't worry about the gain problem. The gain, the lesser gain give you the very wide coverage. Okay, in the short distance, but you have the more wide coverage area. If you're choosing those of the high gain antenna, when we're going to select the high gain antenna, because we want to cover the far distance. Okay, the high gain antenna basically give you the very strong power, allow you to cover even further distance. But those around here, they can't able to get any signal. Okay, that's the difference between a low gain and high gain. The beamwidth. An antenna pattern usually has 2 or more loops. So the main loop have the most powerful radiation, and the other loops are the back loop or the side loop. The beamwidth is the angle between the half power point of the main loop. So when reference to the peak effective radiated power of the main loop. Okay, right here they show you some of the picture. So the coverage should look like this. When you look at the main loop right there, actually the main focusing is on these places. The other place is all just a side loop. And this is the measuring power. So the measuring power, the dBm, absolute power value, by giving the formula 10 log, and then this one will be the power, then you need to divide by 1 milliwatt. So maybe I can give you some of the example here and doing the calculations. So I will going to take out my calculator. Okay, so this calculator. So what is the value if I going to using the power? Okay, this power is 1 milliwatt. Okay, so now the 1 milliwatt is equal to how many dBm? So we can just using this formula. It's very simple to use. Okay, so 1 milliwatt divided by 1 milliwatt. So still is 1 milliwatt. Okay, still is a 1. Okay, because 1 divided by 1 is still 1. And then log. Okay, becomes 0. 0 times 10. Okay, so it's 0. So that means 1 milliwatt is equal to 0 dBm. Okay, so this is the calculation. They also have another is for the dB. So the dB is using the first power and the second power, okay, to do the calculation. So if you want to understand about the calculation, they also have some of the calculation between the dBm convert become the milliwatt, how to do that. So for some of the well-known dB convert to the milliwatt, okay, it will look like this. So maybe I can try to give you some of the example calculation for what we know. It's now have the 1 dBm, and the other one is into the milliwatt. So now, just have already done the calculation. 0 dB is equal to 1 milliwatt. Okay, just have already calculated for you. Okay, how about for the dB in 3? So the 3 dB here, they become 1 times 2. So you become 2. Okay, don't worry, if you don't believe, you can actually try to use back the formula just now I'm showing you. Okay, and try to calculate. Is it I put the 2 milliwatt here, I'll get the 3 dBm, right? And then the 10. The milliwatt will be 10. Then the dBm here, if I put -3, the milliwatt here will become 0.5. Minus 10 dB is become 0.1. Okay, so let me redraw it. So this one you become 0.5 is half. Okay, minus 10 is 1 divided by 10. Okay, that's why you become 0.1. This one is 0.5. So now I give you the example how to convert. Okay, now by giving is 26 dBm. So 26 dBm is equal to how many milliwatt? And the answer is, okay, we can use the most easier way to doing the calculation. Like right here, I know the 26 dBm is one of the combination is using all the dB from here. So I can put this one. We start from the 10 first. 26. Sorry, 26 is a combination is 10 plus 10 plus 3 and 3. Okay, so this one is the dBm. Okay, all is dBm. And then I want to convert the dBm become milliwatt. So when I want to convert become the milliwatt, so the 10 dBm is equal to 10 milliwatt. So this is 10. So when doing a converting, you have to change this plus become time 10. Okay, because 10 actually become 10. So now the first 10 have to time by the second 10. And the 3 here. 3 inside the dBm when convert become the milliwatt, become 2. Okay, this one become 2. So it will become 10 times 10 is 100. So 100 times 2. So it will become 200, then 400. So this is the answer for the 26 dBm. Okay, so this is the formula for you to understanding the how to doing the calculation. Hopefully this one will help you. And the last one here, the reference source of dBi is the omnidirectional antenna. The reference source of dBd is dipole. So now they already give you 0 dBd is equal to 2.14 dBi. Content number 4. Other components. The power splitter. So this one allows to split a channel input signal into 2 or more channels. So the commonly used power splitter type are 1 to 2, 1 to 3, and 1 to 4. And this one, 1 split to 2, 1 split to 3 or 4. And the other one is the microstrip splitter and the cavity splitter. Okay, this is a microstrip and this is a cavity splitter. So cavity splitter, okay, this one is applicable to the high transmit power. When working for a long time, the cavity splitter is never than the microstrip splitter. Okay, so this is most recommended use one. Only the microstrip splitter can use as the combiner. What does this mean? So this means this one can do in the reverse way. So the most common one, what we do here is we're going to put our RF cable, the fader line. This one is an input and going to split into 2, and this is the output. For this, the microstrip splitter allow you to do in the reverse way. So the 2 fader line can in here and come out from one side. We can combine, become one, or we can do in the reverse way. Okay, the coupler. Divide the singles of the channel into 2 channel uniquely. So commonly used coupler are 5 dB, 6 dB, 7, 10, and 15. So this is input for our fader line. Okay, so this is the straight in and the straight to, and this is a coupler. So this one will depend on what is the model that you select. So if you're going to select this one is the 5 dB, so that means the signal strength come from here. The strength will be going to minus 5 dB. Okay, minus 5 dB. Example, my original power is 20 dB. So this is the reason why when you purchase some of the AP, they will list up what is the transmit power from your AP. So when your AP have the transmit power 20, okay, go through the fader line and connect it to this coupler. So the 20 dB coming out from here will be minus 5 dB. So the strength is only remaining 15 dB. Okay, so when you're choosing this one, you have to choose carefully. Okay, well, they have so many models right here. Then the next one, combiner. Combine radio signal of multiple system and the distributor receiver the signal over one channel to port of each system without interference. Combiner are classified into single band, okay, and the multiple channel combiner. So they allow us to combine 2 different wireless, like one is for WLAN and the other one will be used for the GSM or 3G. So you can combine these 2 together and the output through one ANT. Okay, 2 fader line in, and when they come out, it's only 1 fader line. So with the combiner can help us to save a lot of the cost for using the fader line, because the cost for purchasing the cable line will be quite expensive. Okay, it will be depend on how far away that you want to use. And the combiner also allow us to combine 2 different channel WLAN together. Then the next one, the RF coaxial cable, or we can call it a fader cable. So from the table here, we'll notice they have one half super flexible fader and a half fader. So what's the difference here? This place is giving the example. The half super flexible fader, the radius is 40 mm, and the half one is 80 mm. So this is thin tender half fader. So if you're using the thin fader line cable, so they'll cause the high loss. Every 100 meter, they'll cause 19.2 dB loss. If we're choosing the thick one, the thick fader, the fader is only lost 12.1. Because the thick fader line, they have more protection, can cover the signal loss. Okay, but in a chance, the half fader is very difficult to deploy at the corner area, because it's very hard for you to bend. Alright, so we have to consider about the surrounding and the area, the location, whether we can use this or not. So the temperature can last at minus 30, okay, to 60. Other requirement, okay, this is all about the RF cohesive fader. Okay, then the next is connector. This is the N-type. The outdoor AP N-type connector, okay, will be look like this. And the next one, the FR cable N-type connector, used to connect to the RF cable, like just now the cable. And the dual mu N-type connector is used to connecting the AP and the antenna. So maybe I don't want to connect to the fader line. I just want to connect the AP here direct to my antenna. Then you can using this. Dual female N-type connector. So this one is used to extend the length of your cable, the RF cable. Maybe it's not long enough, so you want to extend the size. So you can using this one to connect, to join two different RF cable. The SMA type. Okay, this is SMA type. Polarity reversal SMA. And this is some other protection component. Stage protection device. This one will be used in between the antenna and the AP, used to protect the AP, prevent the damage. Okay, and this one will be using for between the AP and the switch. So mainly used for those outdoor AP, because you deploy the outdoor AP on outside the building. So when have the lightning strike through the outdoor AP, at least they can still protect your the intranet, won't be damaged by the electric. And here is some of the example, okay, for how to using the accessory here, the combiner, the coupler, and also the power splitter. So we can using the combiner combine the WLAN AP and the base station together. Okay, instead of going to purchasing so many fader lines to join them together, because if I don't using the combiner, what will happen? I have to spend more money to purchase the antenna and also the RF cable. So right now we need to spend so much for that. I just using a combiner, join these two, become one output. So this one output, I'm using the coupler here to split the power. So here require the less power, and here require the more power, because later on I'm going to split on two different antenna. Okay, summary. Antenna concept. Okay, working mechanism, antenna parameter, and other component.